Okay, so we talked about this. We talked about this. I think you have write it down on your notes already, so I'm going to write it down just in case you didn't. We're going to say this is a f of x that's equal to the functions. And the f inverse of x that's equal to the f inverse of x. And so that's how we read it as. But in order to function have inverse, we say we must have what? In order to have inverse, must have what? You must fulfill those two conditions. So two conditions. So first one, which is what? Monotonic. Do you guys remember that word?
Yeah.
That means what? Strictly increasing or decreasing. Two, it must be past horizontal line test. We talk about that as well.
We need an extra S.
What?
For pass, extra S.
Oh. Past horizontal line test. And the result, what we're talking about result, what kind of result you're gonna have? Result is you're gonna have the f of x and f inverse of x graph is gonna reflect across what? Y equal to x. So that was a big deal. And the second thing is coordinate swap. So coordinate swap. We're going to talk about that coordinate swap. Okay, so those are the few things that can happen. And then we say, hey, we have a, remember one of the homework yesterday was like this. I think it's 4, something like that. I think it was this. Yesterday, one of the homework questions says f of f inverse of 4. Do you remember that?
It's f inverse of f of 4.
Right. So I don't even need to know the function. I know the answer. The answer is 4. You're like, why is that? Well, we're plugging in 4 into the inverse. But inverse has a swap coordinate, and we plug it back in. So you inverse of the inverse, right? You have a function and you inverse, you kind of just change place and change back. It's like me changing the seat of Gabriela and then change back. And I say, where is Mr. Ye? Wow, magic. I'm back to here, right? Because we switch and we switch back. That's pretty much what happened here. So I don't even need to know the function. We just need to make sure the function, it has strictly increase and strictly decrease. So we're going to experiment one of the function. One of the function we're going to pick is as y equal to 3x minus 4. Right?
Right.
So we're going to call this f of x equal to 3x minus 4. We're going to say x equal to 3y minus 4. And we're going to say x plus 4, 3y. Y is equal to x plus 4 over 3. That's equal to f inverse of x. Are we okay here?
Yeah.
Okay, so now we're going to graph both functions. So, Benjamin, you're going to help me. Because I'm going to be a cameraman and you're going to be the computer man. Okay, you're going to turn off the projector and you're going to open a new window to the Desmos. All lights off. Okay, are you going to open a new window? Okay, go to Desmos. And we're going to start graphing. We're going to graph f of x equal to 3x minus 4.
3x minus 4.
Mm-hmm. And we're also going to graph g of x, which is the inverse function, g of x. So we're going to know is equal to parenthesis x plus 4. There you go. Okay. So right now you probably see just two lines intersecting each other, but we didn't talk about the result. So we need to graph the third function there, y equal to x. What do you see? And you can zoom out a little bit to let students see more. See, it's just reflecting across the green line. So this is a very powerful tool though. Why is it a powerful tool? Now, I want to see here is that powerful tool is right here, that this line is reflecting to, I think this is like a mirror, and it's reflecting across. So, okay, but not only that, look at the coordinate swap. So I'm going to pick any coordinate here. Let's pick something like 6, 14, right?
So it should be 14 to 6.
Right, so at the other side should have 14, 6. So the coordinate swap, this is a very useful tool. Why is that a useful tool? Because that's going to be something that we can use later. We can say, okay, that's going to help me solve a lot of different kind of questions, including go all the way to calculus, those differential inverse functions, derivative of inverse function, and it's going to use the same idea. And the things like, if you understand this, you can understand the highest level of mathematics. Okay? The highest level of mathematics. Because in the precalculus, it basically composed of all different kind of things that you had to understand the inverse. For example, sine function, sine inverse functions, cosine function, inverse cosine function, logarithm function, exponential function. They are all inverse to each other. So you have to make sure that you understand all this. So that coordinate swap is going to be very powerful. So let's turn off the light and we can go back to talk about different things.
Was that your phone screen?
What? Am I using it? No.
So you still have one, but I wasn't using
Okay, what I'm going to do is I'm going to create a function. I'm going to create a function that is past strictly increase. So I'm going to take this functions, and I'm going to go with this, and I'm going to go like this. I'm going to change the slope from 2 to 1/2. So it's going to be like this. So I have this function, and this function we can call it f of x. Okay. Nicholas, can you find me the green marker?
green?
Oh, black for this? I have green, sorry. So this is f of x. So here's my question. I want to find, I don't give you a graph of f inverse of x. I'm going to ask you find f inverse of 2. Okay? So I didn't ask you to, I didn't have a graph of f inverse of x, but I have f of x. Okay? So this is a very cool question. How can you do this question in less than 5 seconds? Okay, don't shout it if you find the answer. You can write it down and let me see if you're right. So I didn't give you an inverse graph. I give you an f of x graph. And f of x is allowed to have inverse because it is past horizontal line test. But I'm asking you what's f inverse of 2. We're not asking you what's f of 2. f of 2 is easy. f of 2 is equal to some other value, but we ask you f inverse of 2. If you think you know the answer, you let me know, raise your hand. It's a cool question. Write it down. I'll see if it's right.
Question mark. See, here we go.
Good. Good.
Yay.
Good. Good. Okay. So we're gonna show you the long way first. A long way is take all the coordinates, especially the endpoints, and we're gonna have a coordinate swap. Okay, so this is a long way. So what is the coordinate of this one? Is 1, 2, 3, 4, 5, right? So it's -5, -2, right? Is that okay? So, and I have a coordinate, it's gonna be -2, -5. So -2, -5, so right here. So it's gonna be right here. And we have a turning point as what? 2, 2, 4. Right? And then this one is what?
Whatever, negative.
-2, 4, thank you. And this one's 4 what? 8? So obviously we're gonna have a -2, 5, -2, -5, and we're also gonna have what?
If the 8 is supposed to be 7.
7.
Yeah, it's 4, 7.
Somebody can count, thank you, Benjamin.
Benjamin.
Okay, -2, -5, and this is -2, 4, so it's gonna be 4, -2, right?
Yeah.
4, -2, so it's gonna be right here, I think.
Yep.
And then this one is 7, 4, so 7, 4, so it's 7, 4, so 1, 2, 3, 4, 5, 6, 7, 7, 4 is gonna be right here. So we're gonna have this line and this line. And do you see that they are symmetry to this? Do you see that?
Indeed.
Which is F inverse, so this is F inverse, right? So F inverse 2, so that means 2, what's my 2? 1, 2, and roughly at -3 if I have the correct things. But here's a cool way to do it. I don't need this. If you understand the idea of coordinate swap. The coordinate swap is you can say, okay, well, this is F inverse of x. And there is an x value and there is a f, there is a y value, right? Right? And there's an f of x, there is an x and there's y. So there are a table of things can happen. So we want when x equal to 2 and we say what is the question mark? But we know the coordinate is going to swap from here to here. So boom. And that's question mark. So can I figure out, well, that just means f of x, y is equal to 2. When y equal to 2, it's only one time it happened, which is -3. There you go. It's a very powerful tool to figure out one side and the other side, but I can figure out just by original function. I don't need to go to inverse. How many of you guys are lost? How many of you guys can explain blight better?
Wait, explain better.
Okay, which person you prefer? Okay, Team Josephine, raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9. And how about this Team Benjamin? Oh,
Benjamin.
1, 2.
Sorry,
I'm sorry,
Benjamin.
Josephine is gonna take the lead on this one.
Guys, I'm superior to her in every single way imaginable. I don't understand.
Oh, wow. We got
Everything's on live stream.
Okay. So basically the principle is coordinate swap. So we have regular coordinate x, y, right? So what's gonna happen is that you take the coordinate from the original, and this one we have you know how this is just f of x, but now we're doing inverse, so this is gonna be our x. So we're taking this as our x value. However, in this case of coordinate swap, let's just say that this is f of x. Okay, so this is f of x. But however, we're gonna have on this side, let's just say this is an inverse. It's gonna swap the coordinate. So it looks like this. But it's still gonna represent f. Does that kind of make sense so far? Yes, no?
Yes.
Okay. Yes. So
We're gonna have voting on the bottom, internet voting. Josephine versus Benjamin.
So
That's an
alright, he gives us the only coordinate we have so far is the inverse. So in the inverse, it says that 2 is our x value. And because 2 is our x value in our inverse, that means it has to be our y value in our regular one. Does that make sense? Because they're switching. So if you have your 2, like he said here, if you have your 2 as your x value and the inverse, it switches and it becomes the y value in the regular one. And what you're going to do is that now you have your y value. However, using this graph, you can find what the x value is, which is going to be the same thing as here because their coordinates are just switching. So you take the y value in here, so you have y1, y1, 2, but now you have to see where does this graph intersect where y, this entire, can you shut up? Where this entire line is y2, which is going to be right here. Does that make sense? Or down? I can't read. Down. So down. So right here. So basically, we have to see where the graph intersects, which is going to be here, which is 1, 2, 3. So this coordinate is -3, 2. Do you understand why I'm here and how I got here? Yes, no, yes. I don't say anything. Okay. So now that you have the x value, you have the x value for the regular equation, which is just going to be -3. And in this one, you're going to have it in the y, which is because you're flipping the equation. So you have this for x, you have this for y. So they're going to flip, so you now have this for x and this for y. That's basically just the principle of coordinate swap. Good? Yes? No?
Now Benjamin, you two explain.
Should I?
Yeah, yeah.
Okay.
We're gonna have Team Josephine versus Team Benjamin.
Alright, so.
No, and that is without, it's not like put anybody up or
Yeah.
down. It's just sometimes like, it's like a resonance.
Yeah.
Like some people is more resonance to one person, some person people resonance to one another person. So let different person express, it's not bad.
Alright, so basically, right, so basically guys, right, whenever you have f of x, you know, that's just kind of the equation, right? F inverse of x is literally the opposite. What happens whenever we invert this is that we switch the x and y values, right? So like Josephine said, if we have f of x and then the coordinate, right, x comma y, f inverse of x, the coordinate that we're gonna have is gonna be y comma x. Because what happens here is that we're literally just swapping them, right? So let's say we have we plug in, we were trying to figure out f of 3, right? F inverse of 3. Let's say we're trying to figure that out. Then over here, that's gonna be, whenever we plug anything into f inverse of x, right? That's gonna replace the x value, which means that is the x value of that equation, right? Of that function. So over here, f inverse of x, we have f inverse of 3. So that's the x value. Now, if we're trying to flip that into f of x, we're gonna swap them, right? So x is gonna become y becomes x. So this is gonna move to this side over here, right? This is y. So we're gonna change that into 3 over here. So basically, we're gonna find the y value, right? What f of x is whenever it's 3. So we have 1, 2, 3, and then we go over here, right, across to the f of x. So we can figure out exactly what that would be. So let me make that less confusing.
Thumbs down.
That was a very
Get him off the stage!
boo on you suck. Let's see, easy way to explain this It's a complex something. Alright, so I don't know. Basically, they've already said everything that needs to be said. Basically, you switch the x and y's. So if you're still confused,
Go to
Can you give me the answer?
If you're so confused, go to Just Fees.
no. If you're still confused, go to decimals.
I know.
Yeah.
Yeah, I know. There's not a lot of ways to explain this. That's the thing.
It's literally just flip
Whatever the
Yeah.
x value for the
That's it.
Yeah,
inverse
whatever.
is
Okay,
the
so
f- is the y
for
value
for
the
f of
inverse.
x,
Do
yo,
one with both the coordinates, like you have two.
Well, at least give an answer for f inverse of 3 is. At least write down the answer, then I will see.
that'd be like some.
Maybe
2.5.
Yeah. F is
Negative 2.5.
Yeah.
Yeah, 2.5.
Negative 2.5. Sorry, write
Yeah,
down
negative
negative 2.5.
2.5. 2.5 negative 2.5.
No, it's the regular type.
So let's go the other way around. So let's start with f of x. Yeah. So if we have right. So you guys can solve f of 4, right? Right. So f of 4. If we find that and we want to translate that into f inverse of x, right? So f of 4. We go 1, 2, 3, 4, and then we go up to meet the graph at the y value. So 1, 2, 3, 4, 5, 6, 7. So f of 4 equals 7. Right. So remember, f of x is interchangeable with y, which means that technically we can write this as this. So y equals 7. Right. So f of x equals 4, and then y equals 7. Right. So if we wanted to change that into f inverse of 7, right? Whenever we change it into the f inverse function, the x and the y's get swapped. So if y equals 7 for this, then the x is going to equal 7 for f inverse. So f inverse of 7 is going to equal 4, right? Because another way to write f inverse of x is y.
I'm not gonna put on the bottom, says comment on bottom, thumbs up for
I know, right?
for Benjamin.
It's like
thumbs
vote
up
down
for
below.
Josephine, that's
Yeah.
how voting.
I should have.
Put a poll in there.
Yeah,
I
put
can
it.
put a poll.
What is the there's like one website that a lot of people use, like straw polls or whatever.
Can you do that?
I don't remember.
Can you do that?
Basically, just swap the x and y.
Y yo te estaba intentando enseñarte derivar. Oh,
Good job.
tampoco.
Thank you, Josephine.
Wait, literally, how you were. No, like, how do you explain it?